Hi all, today we will discuss the isomorphism between LVW and Fm by n. LVW is the set of all linear transformation from V to W, where V and W are two vector spaces, two finite dimensional vector spaces over a common field F. Then that set of all linear transformations is isomorphic to Fm by n. So in order to prove the isomorphism, we need to establish a linear transformation from V to W, or we will write it as some psi. We can call this as psi from LVW to Fm by n, which is 1 1 and 1 2. Yes, 1 1 and 1 2. But we know that since the dimension of these two quantities are mn, that means dimension of LVW is same as dimension of Fm by n, you can easily define a linear transformation psi from LVW to Fm by n, which is 1 1, because if this is 1 1, if and what if it should be on 2, we have already discussed some equivalent statements regarding this two vector spaces of same dimension. So we will define, we already discussed the matrix representation of elements of LVW. That means if we have T from V to W, then if we fix a basis B consisting of the vectors alpha 1 etc alpha n of V, and we consider another set of ordered bases or ordered set of vectors which constitute an ordered basis of W, say beta 1 etc beta m. Using these two bases, we can represent any linear transformation T from V to W as a matrix form, that is a matrix related to T with respect to relative to B and B prime. So that matrix is represented by this form, this notation. Then this would help us to define a linear transformation from LVW to this set of all matrices Fm by n, because this matrix is always an m by n matrix. So we define psi of a linear transformation T in this as the matrix of T relative to the basis B prime. This is for all T belongs to LVW. So this is we'll prove that this is a linear transformation first. So we, in order to prove psi is a linear transformation, we consider psi of C plus Ct plus U. T and U are two linear transformations from LVW, and C is a scalar from F. So this is, by definition, this is the matrix of Ct plus U relative to the basis B and B prime. So this can be written as C times matrix of T relative to B prime plus matrix of U relative to the basis B prime. This is already discussed in the previous classes. So you can write this as equal to C times psi of T plus psi of U. So this this shows that the psi is a linear transformation from this vector space to this. Now we can verify the 1 1 as the psi is 1 1 because when you write the psi of T equal to 0, that implies what is psi of T? Psi of T is the matrix of T relative to B prime, so that is 0. So all the entries are 0. That means if T is equal to the matrix of T is equal to, if the matrix of T relative to B prime is represented by some A, the matrix A consisting of Aij, then the definition is T alpha j can be written as summation I equal to 1 to m Aij beta j. This is beta I. So this is the definition of the matrix of T. When you assume this psi of T equal to 0, you can get this matrix is 0. That means this is 0 matrix. It is 0 matrix means all the entries of this matrix are 0. That means each coefficient is 0. Then you can get this is equal to 0 for j is equal to 1, 2, 3, etc. N. Okay, so T alpha j equal to 0 for all n. Now this shows that whenever T alpha is equal to T of some x1 alpha 1 plus etc. xn alpha n, because any alpha can be written as x1 alpha n plus xn alpha n, but we know that each t alpha j is equal to 0, then therefore this x1 times 0 plus etc. xn times 0, that is equal to 0 for all alpha belongs to V. This shows that this t is a zero transformation. That means for every alpha belongs to V, this t is a zero transformation. Image is 0, t alpha is 0. That means whenever psi of t equal to 0 implies this t is equal to 0. This shows that this psi is 1 1. We already discussed the equivalent statement. If dimensions of two vector spaces are same, then 1 1 implies if and only if it is on 2. Therefore this 1 1 implies psi is also on 2. Therefore this psi is an isomorphism. Okay, so this isomorphism, these things can be in the textbook, these things are termed as theorem 1. That means the representation of the matrices, and we can as a consequence we can prove that LVW is isomorphic to Fm by n. So this is our theorem 1, theorem 11. So there is no proof for this theorem, so you need to write out all these as a proof of that theorem. In theorem 11, it is stated that the existence of the matrix representation and the 1 1s, and in theorem 12 we can see that it is stated that these LVW and Fm by n are isomorphic. So these things, the topic discussed in the previous class, and along with this can be considered as theorem 11 and proofs of theorem 11 and theorem 12. So you need to write out the notes as the proofs of these two theorems.